All right, so we're going to be looking at a bunch of different things in this particular video. This is the practice for lesson 10. We're going to be looking at problems 1, 2, and 3. So this one's looking at this table, and they want us to figure out whether it is proportional or not. So the easiest row that we can use is this one here, where our hours are going to be our X, our dollars are going to be our Y. To find our constant proportionality, we use K is equal to Y over X. So we're going to put our Y is 50 and our X is 4. That fraction means 50. Can't write a 5. 50 divided by 4. 4 goes into 5 one time. This is the remainder of 1. Bring down our 0. That's going to go 2 times. We had our decimal and our 0, decimal up, 0 down, and that goes 5 times. So our constant on that row is 12.5. Now we need to check and see if these other numbers in our X column, if multiplied times the constant, will it give us our numbers on the right? So as you can see, I went ahead and did my multiplication. In red, I did 12.5 times 7. That did give me 87.5. So that row checks out. I did 10.5 times 12.5 in blue and got 131.25. And 12 times 12.5 is 150. So his earnings are proportional, and we just explained our reasoning. Now they want us to write an equation relating his earnings in dollars. So E for earnings and T for time. If we go back to the equation, we see our Y is our earnings. So the format that we use to write equations is Y is equal to KX. So in our table, we said the Y was our earnings. So E instead of Y. We know that our constant proportionality is 12.5. And from our table, our X is our amount of hours. So that was T. So for part C, they want us to use that equation. E is equal to 12.5T. And they want us to figure out how many hours does he need to work to make $62.50. I'm going to write over letter D on this one. So his earnings would be $62.50. And then 12.5T would be here. So to get T by itself, we would divide both these sides by 12.5. So that would have us doing, move the decimal one time. It would be 625 divided by 125. Which would give us T on this side, because 12.5 divided by 12.5 is T. And 6250 divided by 12.5 is 5. So he needs to work 5 hours to get 6250. For part D, we're using the same exact equation, even though they give us the time, because these equations can work whether they give us the earnings or the time. So we're looking to find E. That's going to be equal to 12.5 times the number of hours he has here, 17. And that would give us his earnings is equal to $212.50. Number 2, Yuyan can drive an average of 23 miles for each gallon. So we're writing an equation for that. So our gallons is going to be our X, and our miles is going to be our Y. So we're using Y is equal to KX. The Y is going to be our miles, which they want us to put M, is equal to, the constant is, they give it to us right here because it's 23 miles per gallon. So 23. And then our X is going to be our gallons, and they want us to use G. So if he plans to drive 391 miles, we're going to replace the miles with 391. Divide both sides by 23. And doing 391 divided by 23 lets us know that he would use 17 gallons of gas. For letter C, we're using the same equation. This time we want to know how many miles he can go if he uses 12 gallons of gas. So we're doing 23 times 12, and that gives us 276 miles. And the last one, we've got a graph to use. It says, are the number of the pints proportional? So to find out whether it's proportional, we can draw our straight line. We see it is straight, comes out the origin, and touches all the points. So yes, it is proportional. Now we're going to create an equation. So y is equal to kx is the format for that equation. Our y-axis is here, and that is the ounces. They tell us to use a z for that. Our x-axis is over here, and that's our pints, and they tell us to use a p for pints. So now we need to find our constant of proportionality. Normally you could go to the 1 and follow where the line is, but I don't know if that's 10 or 15, or I just know it's between 0 and 1. So we need to look at where our lines, where we have a line, a dot on the line at. So we've got 3 and 48. So k is equal to y over x. Our y coordinate there is 48, and our x coordinate is 3. So when you do 48 divided by 3, you get 16. So 16 is going to be our constant of proportionality here. Then it says a recipe requires 11 pints of water. So we want to find out how many ounces we need, how many pints of water, or how many ounces are in those pints. So Z, they give us the pint, so we replace the pint with 11. So here we need to do 16 times 11. And that gives us 176 ounces. Next one says an average ice cube contains 1 fluid ounce of water. He puts 64 ice cubes into the pitcher. When it melts, approximately how many pints? So now we're looking for the pints. They're giving us the ounces. So Z is equal to 16P. Our ounces are going to be 64 because there are 64 ice cubes there. 16P. We need to divide both sides by 16. So that's going to give us P on our right-hand side. And then we do 64 divided by 16, which gives us 4 pints. The last one here is about the heartbeats. We're trying to find the unit rate. Unit rate means we're trying to find the constant of proportionality, y over x. Our x variable is the one that we can just pick out of the sky. How many times does your heart beat in 10 seconds? How many times does your heart beat in 100 seconds? All of those numbers are going to be time. Time is usually your independent, so it's always going to be your x. So we're going to put 20 over 15. We'll go ahead and do 20 divided by 15. And if you do it as a decimal, you're going to have a repeating decimal of 1.33333. But if you do it as a mixed number, it's going to go 1 time. You'll have a remainder of 3 and a remainder of 1, and your divisor was 3. So your constant proportionality, or your unit rate, is going to be 1 1/3. What does that mean in this situation? It means that a heartbeat, or your heartbeat, beats 1 1/3 beats per second. Writing that equation now is going to be y is equal to kx. We obviously know our k is 1 1/3. Our y, we said, was our heartbeats. So I'll put a H for heartbeats, and then a T for time. Time is, again, always going to be our x. And then at this rate, how many times does your heart beat in a minute? Well, since we're talking about seconds, we're looking to find the heartbeat, so we leave that as that. We're doing 1 1/3 times. The time is in seconds, so we want to find 1 minute. That's going to be 60 seconds. So to find that number, we're going to be doing 1 1/3 times 60, which is going to give us 3 times 1 is 3 plus 1 is 4. So that turns into 4/3 times 60 over 1. That's going to give us 240 over 3, which then can be divided and become 80. So in 1 minute, your heart beats 80 beats. Oh, nope, sorry, this is the last one. You pay $1.80 for 12 pencils. We find our unit rate. K is equal to y over x. the number of pencils is going to be our independent variable, because we can just pick however many pencils we want to buy, and that's going to determine how much the cost is. So it's going to be $1.80 divided by 12, and that gives us 15 cents. What does it mean in this situation? Price of pencils is 15 cents per pencil. Writing that equation is going to be y is equal to kx. Again, our y is going to be our price, our money, our cost, or whatever you want to put for that. I'm going to put C for cost. Our constant is 0.15. And then our x is going to be however many pencils, P, you buy. It says how many pencils can you buy with $12. So if the cost is $12, the rest of the equation stays the same. To get P by itself, we divide by 15 cents on both sides. That's going to give us P is equal to on the right hand side. And then to clear up the left hand side, we do 12 divided by 15. And that gives us 80. So we can buy 80 pencils with $12. Now for the exit ticket for lesson 11, these numbers right here, we're going to be looking to find, it says Nora earns a constant amount of money for each mile she rides. She rides 14 miles and earns a total of $235. How much money does she earn for each mile? That means unit rate. So we're trying to find a constant proportionality. So K is equal to Y over X again. Our Y is going to be, again, that's our dependent variable. What depends on the other thing? Well, the amount of money she makes is going to depend on how many miles she rides, which means it's our dependent variable, which means that the miles is our deep independent variable, our X. We can pick any number of miles we want and determine how much money she makes. So our Y is going to be 235.90. Our X is going to be 14 miles. So you can see the math right there. We're going to get a constant proportionality of $16.85. So she makes $16.85 for every mile she rides. And then it's the same thing with Sean. Sean earns $13.25 for each mile he rides. Sean earns a total of $251. We want to figure out how many miles does Sean ride. So if this is his dollar amount, and then this is his constant of proportionality, that's his unit rate, we only need to do $251.75 divided by 13.25. Got to move that decimal twice and move this one twice. So your new problem becomes 25,175 divided by 1,325. And that gives you an answer of 19. So 19 miles he needs to ride for $251.75. Now lesson 12, this is the one that we did today in the second block and third block. Taking a look how to fill in this table. Basically all of our information would have to come from either this row or this row, because it's the only one that gives us two numbers. I am not going to be worried about the third row as of right now. We're just looking at this as a regular old table. So we want to find the constant proportionality. I want to find it right here. So constant proportionality is going to be Y over X. And currently looking at this table like this would be my X and this would be my Y. So a 4 over 9. So my constant proportionality right here would be 4/9. To go from the first row to the second row. Even this one's going to be 4/9, but I don't have to do that one because the number's already there. So I want to see what number times 4/9 would give me 1. So to do that, I'm going to do it backwards. I'm going to do 1 divided by 4/9. Put a 1 underneath this. We do keep, change, flip. And you get a number of 9/4. So I can go ahead and leave that like that as 9/4, or if you want to simplify it, 9 divided by 4. 4 goes into 9 2 times. That would be an 8. Leave you a remainder of 1, and your denominator stays 4. So 2 1/4 would be the number that needs to go there. For the next row, we would be doing 6 times 4/9, which would give us 24 over 9. And then 24 over 9, so you could just leave that like that if you would like. Or you do 24 divided by 9, which goes twice. So that would be 2 6/9, which you can then simplify to 6/9 to 2 2/3. Divide both of those by 3. So 2 2/3 is the number I'm going to put there. Obviously, the 9 and 4 are already done. So then on the fourth row, you don't have a number in the front, so you have to do it backwards. That would be 2 1/2 divided by 4/9. We would change that. 2 times 2 is 4 plus 1 is 5. So that's 5/2 divided by 4/9. Keep change. Flip that. Now that it's two fractions. That's going to give you 45 over 8. So 45 divided by 8 goes 5 times. Leaves you a remainder of 5. So the number I'm putting there is going to be 5 5/8. So now that we got all of that work taken care of, I can go ahead and now look at the third row, where the third row is just our total. We mix in the yellow and blue paint together to get our green paint. So I just need to add these numbers. So I've got 2 1/4 plus 1. That's going to give me 3 1/4. We've got 6 plus 2 2/3. That's going to give me 8 2/3. We've got 9 plus 4. That's 13. We've got 5 5/8 and 2 1/2. That's going to require some work. So we got 5 5/8 plus 2 1/2. We've got to have common denominators. I can turn a 2 into an 8, so I'm going to leave 5 5/8 alone. The 2 stays the same, but this I'm going to have to multiply times 4 to make it an 8. I do the same thing to the numerator. So that's going to give me 4 8s right here. So 5 plus 2 is 7. 5 8s plus 4 8s will give me 9 8s, which means I can then take a whole out of that, 8 8s, and give it to the 7. So that's going to be 8. 9 8s minus 8 8s is going to leave me with 1/8. So that's going to be 8 1/8. And then our table is completed. Now we're going to have to use that table to come up with an equation. So for the next part, it says, write an equation to describe the proportional relationship between the volume of green paint and yellow paint. So we're making an equation with green paint and yellow paint. So I'm going to do that right up over here. We're looking at green paint and yellow paint. Yellow paint comes first, so that's going to be our X. Green paint comes second, so that's going to be our Y. We're going to do Y is equal to KX. The Y is green paint, so we put a G. The X is yellow paint, so we put a Y for the X. Now we need to figure out what is the constant of proportionality. K is equal to Y over X. And we can look at any of these rows that have whole numbers and make it easy for ourselves. I'm going to look at this row that we first started with. The Y, again, is green, so that's going to be a 13. And then the yellow is a 9. That's our X, so we're going to put that here. And then you don't even have to simplify that. You can just leave it as 13 over 9. And that's our equation. G is equal to 13 over 9Y. For the next equation, it says to talk about green paint and blue paint. All right, so if we're talking about green paint and blue paint, so it's green paint, blue paint. Blue paint comes first. That's our X now, so it's no longer a Y. And this is stayed our Y. So Y is equal to KX. The Y is green paint. The X is our blue paint. And now we need to figure out the constant. K is equal to Y over X. We go right back down here. So Y is 13. And our X is 4. So 13 fourths is good enough for a constant proportionality. Okay, I hope this helped you. If you have any questions, please bring them up in class on any of this stuff. Let us know what I can do for you and what other examples you need, if need be, or some clarification on one of these questions.